Assalamualaikum warahmatullahi wabarakatuh. Um, Allow me to introduce myself. My name is Ardian Daniswara, and in this video, I am gonna present the assignment about numerical solutions for partial differential equations. So let's get into it. So here's the problem. The given image presents a problem involving the numerical solution for partial differential equations for a specific geometry like this. The geometry and dimensions are specified in this image, and the assumptions include a 3D incompressible steady-state flow with viscosity. So before we start the solution, we have to stay conscious and we have to do intention. The intention is to solve the flow problem through the given geometry using a numerical method. And then the initial thinking is to understand the problem and assumptions, such as a 3D incompressible flow, steady-state conditions, given geometry with specific dimensions, and of course the fluid properties, in this case a viscosity. So the idealization is to idealize the problem to make it manageable for numerical analysis. This involves setting up the governing equations for incompressible flow, the Navier-Stokes equation for incompressible flow, and the continuity equations for mass conservation. And we begin to solve this problem by following the instruction set. Just follow the steps to solve the PDEs using a numerical method such as the finite element method. You can use any software to solve about the fluid mechanics problem like NCS or GFDsoft. So this is the governing equations that used to solve the problem. So we have here, there are two equations. The first one is Navier-Stokes equations, and we have the continuity equation. So this is the numerical solution steps. First, geometry and mesh. Define the geometry of the domain based on the given dimensions. Length is 0.3 meter, 0.2 meter, and 0.3 meter. The height is 0.2 meter, and the inlet and outlet conditions as specified. And then discretize the geometry into finite elements or meshing. And about the boundary conditions, define boundary conditions for the flow problem. So here's the problem. The inlet velocity or pressure, outlet pressure, and no slip conditions on the walls. Discretize the equations. Convert the continuous PDEs into discrete form using FEM or finite element method. Set up the finite element mesh and interpolate the variables over the mesh elements. Then assemble the system. Assemble the global system of equations from the element equations. Apply the boundary conditions to the system. And we can solve the system by use an appropriate solver, like iterative methods in the numerical solutions to solve the system of equations for the flow variables. In this case is velocity and pressure. And then we post-processing, analyze the results to ensure physical correctness, and then plot the velocity and pressure distribution within the domain. And we can validate the numerical results with theoretical or experimental data if available. I think enough for this video about solving numerical solutions for partial differential equations.